Why don't scientists trust atoms? Because they make up everything. Now, on a more serious note, you ever found yourself gazing at the night sky, wondering how it all began? What sparked the birth of the cosmos? The universe, in all its vastness and mystery, has always invited such curiosity. It's a puzzle of cosmic proportions, a tale of origins and destinies, of stars and galaxies, of time and space. This curiosity, this quest for understanding, has driven scientists to delve deeper, to explore further, to question more. These questions have puzzled scientists ages, leading to the development of the Big Bang Theory. The Big Bang Theory starts with a singularity, a point of infinite density and temperature. Imagine a point so small it's impossible to measure, yet so incredibly dense that it contains all the mass in the universe. This concept is what we refer to as a singularity. It's a term that hails from the field of physics, describing a state where the laws as we know them break down. In the singularity, there was no space or time as we understand it. Picture an existence where everything is entwined into one single point, with no room to move or breathe, and no clock to mark the passing of moments. It was a reality beyond our current comprehension, a place where our understanding of physics holds no sway. However, the singularity was not a static state. It was a point of unimaginable intensity and potential, brimming with energy ready to burst forth. From this singularity, the universe as we know it began to expand and evolve. Imagine an explosion of unimaginable scale, with matter and energy spreading out in all directions. This is the Big Bang, a massive outburst that marked the birth of our universe. But it wasn't an explosion in the conventional sense. It was an expansion, an unfurling of space itself. In the immediate aftermath of the Big Bang, the universe was a hot, dense soup of particles. It was so hot, in fact, that atoms couldn't form. But as the universe expanded, it also cooled. And as it cooled, it changed. This cooling process was rapid, occurring over a fraction of a second. As the universe cooled, protons and neutrons came together to form the first atoms, primarily hydrogen and helium. These atoms would become the building blocks of everything we see in the universe today. This expansion and cooling allowed the universe to transform from a hot, dense state into a cooler, less dense one, paving the way for galaxies to form. As the universe continued to cool and expand, matter began to clump together, forming stars, galaxies, and eventually, planets. The aftermath of the Big Bang was a turbulent time. It was like the universe had just thrown the most epic party, and now it was time for the cleanup. Space was filled with a dense, hot soup of particles, and as it cooled, these particles began to coalesce. This was not a random process, but one directed by the gravitational pull of dark matter. The first to form were stars, blazing hot and bright, born from the pressure and heat of dense pockets of hydrogen and helium. These stars weren't loners, though. They gathered into vast families we now call galaxies, bound together by gravity's relentless grip. Within these galaxies, smaller pockets of matter began to form planets, orbiting their parent stars in an intricate cosmic ballet. It was a slow process taking billions of years, but the universe was patient. Over billions of years, the universe evolved into the vast, complex system of galaxies and celestial bodies we see today. So, what does the Big Bang Theory tell us about our universe? Well, it's no small task to summarize the grandeur of the Big Bang Theory, but let's give it a shot. Picture a dot so tiny and dense that it's almost incomprehensible. This is the singularity, the starting point of everything. It contains all the mass, energy, space, and even time that the universe will ever hold. And then, in a fraction of a second, this singularity expands. It's not an explosion, but an expansion of space itself. This moment, the Big Bang, is the birth of our universe. The heat and energy of this event are so intense that they create the fundamental particles that will eventually form atoms. As the universe continues to expand and cool, these atoms start to come together, forming stars, galaxies, and eventually, everything we see around us. The incredible thing is that this expansion is still happening today, billions of years later. The Big Bang Theory doesn't just explain where the universe came from, it also gives us a roadmap to its future. It tells us that the universe is ever-changing, ever-expanding, and filled with infinite possibilities. The Big Bang Theory, while not definitive, provides us with the best explanation for the origins and evolution of our universe, a testament to the power of scientific exploration.